So let's do an example and explain the methodology. So there's 4 steps we want to do. Basically, we want to find our stationary points. That is when y dash is going to equal 0, hence our gradient is equal 0, therefore it is a stationary point. We want to determine their nature. Are they going to be a maximum or are they going to be a minimum by using, I've used 2 different things here, but y dash dash or f dash dash x, greater than 0, less than 0, maximum or minimum. Find our endpoints using our domain that they've set out in the question. They give you this, and then we're going to sketch our curve. I would say these 2 are going to take up the majority of your time. Step 1, then step 2, because you can have like 3 different points, stationary points, and then you're going to have to go through and find all the different the natures of them. So this is where the majority of your time is going to be kept up. These last 2 points, last 2 steps aren't going to take that long. It's this that you're going to be working through. Okay, so we've got an example. Find the maximum and minimum values of the function fx when the function is x squared minus 4x plus 3 in the domain minus 4 our domain is going to be from minus 4 to 3. Okay, so we're working within this domain, and this is our function. I'm going to quickly find these 2, my f-dash x and my f-dash x, just because I like doing that. It's a good little habit. Okay, so straight off we can tell with our step 2 it's going to be greater than 0. So because it's greater, it's going to be a minimum because it's going to be a concave up. So we know step 2, whatever points we get, doesn't matter what we get, probably only get 1 point, it's going to be a minimum. Okay, it's going to be concave up. So let's do step 1. Let's make y dash, sorry, I should say, skip to the same thing, fx, f dash x equals 0. So that is our 2x minus 4 equals 0. Put the 4 on the side, divide by 2, x is going to equal 2. Okay, so I've got that. I now want to find my y value of that. Oops, I should bring it up, sorry guys. Now I'm going to put that back into my original function to find my y value. So it's going to be y equals 2 squared minus 4 times 2 plus 3. That's going to be 4 minus 8 plus 3. That's negative 1? Yeah. Negative 1. So our stationary point is 2, negative 1. Okay, now we know straight away, if I do step 2, I'm just going to explain it to you rather than write it down. Determine the nature. Well, I've already found f dash dash x, and that is greater than 0. So like I said before, that's a minimum, it's concave up. So I know that my point 2, negative 1 is going to be a minimum. Okay? I should just prove that and show how to do the proofing, but it is pretty easy to understand. F dash dash x equals 0. I know, it's more like testing the nature of it. F dash dash x equals 2. It's greater than 0, therefore concave up, and 2 minus 1 is a minimum. I should write this turning point. Okay. 3 is finding our endpoints. So here we're just finding with our values negative 4 and 3, just find the y values and just plugging them in so we can sketch it. That's all this is. So if we have our original function of y equals x squared minus 4x plus 3, if we're finding with minus 4, it's going to be minus 4 squared minus 4 minus 4 plus 3. It's going to be 16 plus 16 plus 3. 35. Okay. And when x equals, what was my other one? 3. This should also be positive. 3 squared minus 4 times 3 plus 3. It's going to give 9 minus 12 plus 3. Oh, it's going to give 0. Okay, that's fine. So our two endpoints are negative 4, 35, and 3, 0. Our last step is to sketch it. It's going to be pretty hard because it's got 35 in it. I'm going to have to do a little bit of a rough sketch, sorry guys. Just more for your understanding. So if this is negative 4, say here, that would be negative 4, 35. Okay, we're taking a lot of liberties with the y value, the y axis. And this is going to say 3, it's going to be 0. So it's going to be about there. Is that right? If that's 4, 3, no, 3 should be a little bit further out. 3, 0. Okay, that's our domain. Okay, between this point and this point, that is what we're working within. Okay, and our turning point was 2, negative 1. So we'll call that one 2, negative 1. So it's going to be about there. 2, negative 1 is our turning point. And our curve is going to be like this. All right. And that is going to be finding the minimum value or the type of inflection point and finding it within that domain.